Using filters. Exam objectives. 3. Describe the web container request processing model. Write and configure a filter. Create a request or response wrapper. And given a design problem, describe how to apply a filter or a wrapper. Section 7. 1 through 7. 3. Introduction. Filters are a recent addition to servlet development. This subject has gained importance and is one of the new aspects of the SCWCD exam. 7. 1. What is a filter? In technical terms, a filter is an object that intercepts a message between a data source and a data destination, and then filters the data being passed between them. It acts as a guard, preventing undesired information from being transmitted from one point to another. For example, a digital subscriber line DSL filter sits between the DSL line and the telephone equipment, and allows normal telephone frequencies to pass through the phone line to the telephone but blocks the frequencies meant for DSL modems. A filter in your email system allows genuine email messages to reach your inbox while blocking spam. These filters screen out undesired parts of the original messages. Another example of a filter is in data transmissions over TCP/IP. As it receives the data packets, the lower layer IP removes the information that was intended just for that layer from the data packets before sending the packets to the upper layer TCP. For a web application, a filter is a web component that resides on the web server and filters the requests and responses that are passed between a client and a resource. Figure 7. 1 illustrates the general idea of a filter in a web application. Figure 7. 1. A single filter. It shows the request passing through a filter on its way to a servlet. The servlet generates the response as usual. The response also passes through the filter on its way to the client. The filter can thus monitor the request and the response before they reach their destination. As shown in Figure 7. 1. The existence of a filter is transparent to the client as well as to the servlet. We can also employ a chain of filters, if necessary, in which each filter processes the request and passes it on to the next filter in the chain or to the actual resource if it is the last filter in the chain. Similarly, each filter processes the response in the reverse order before the response reaches the client. This process is illustrated in Figure 7. 2. Figure 7. 2. Using multiple filters, observe that a request will be processed by the filters in this order: FilterOne, FilterTwo, and FilterThree. However, the response will be processed by the filters in this order: FilterThree, FilterTwo, and FilterOne. This is a very simple explanation of filters. As we will learn in the following sections, filters can do much more than just monitor the communication between the client and the server. In general, filters allow us to analyze a request and decide whether to pass on the request to the resource or create a response on its own. Manipulate a request, including a request header, by wrapping it into a customized request object before it is delivered to a resource. Manipulate a response by wrapping it into a customized response object before it is delivered to the client. 7. 1. How filtering works. When a servlet container receives a request for a resource, it checks whether a filter is associated with this resource. If a filter is associated with the resource, the servlet container routes the request to the filter instead of routing it to the resource. The filter, after processing the request, does one of three things. It generates the response itself and returns it to the client. It passes on the request modified or unmodified to the next filter in the chain if any, or to the designated resource if this is the last filter. It routes the request to a different resource. As it returns to the client, the response passes back through the same set of filters in the reverse order. Each filter in the chain may modify the response. 7. 1. 2. Uses of filters. Some of the common applications of filters identified by the servlet specification are authentication filters, logging and auditing filters, image conversion filters, data compression filters, encryption filters, tokenizing filters, filters that trigger resource access events, Extensible Style Sheet Language Transformation XSLT Filters. MIME-type Chain Filters. 7. 1. 3. The Hello World Filter. To get a feel for filters, let's write a simple Hello World filter. In this section, we will look at the 4 steps coding, compiling, deploying, and running involved in developing and using a filter. This filter will intercept all of the requests matching the URI pattern filter and will respond with the Hello Filter World message. Code. All filters implement the javax.servlet filter interface. Listing 7. 1 shows the code for Hello World filter. Java. It declares one class, Hello World filter, that implements the filter interface and defines 3 methods init, doFilter, and destroy that are declared in the filter interface. Listing 7. 1 Hello World filter. Java. Import Java. IO. Import javax.servlet. Public class Hello World filter implements filter private FilterConfig. Public void init FilterConfig this. FilterConfig equal FilterConfig. Public void doFilter servlet request servlet response FilterChain throws servlet exception exception print writer pw equal response get writer pw println html pw println head pw println head pw println body pw println h3 hello filter world h3 pw println body pw println html public void destroy the code that implements the filter in listing 7. 1 is similar to the code that implements a servlet. First, we import the required packages, javax, servlet and java. IO. The servlet request, servlet response, servlet exception, FilterConfig, filter, and FilterChain classes and interfaces belong to the javax servlet package, while the print writer and exception classes belong to the Java IO package. Since we are not using HTTP-specific features in this code, we don't need to import the javax servlet HTTP package. Next, we declare the Hello World filter class. It implements all of the methods declared in the filter interface. We will learn more about these methods in section 7. 2. Compilation. As usual, we include the servlet jar located under the directory C. Jakarta Tomcat 5. 0. 25. Common. lib. In the class path and compile the Hello World filter Java file. Deployment. Just like with a servlet, the deployment of a filter is a 2-step process. 1. Copy the file Hello World filter class to the webinf classes directory of the web application corresponding to this chapter. C. Jakarta Tomcat 5. 0. 25. Webops. Chapter 07. Webinf. Classes to specify the filter class and map the required request URLs to this filter in the deployment descriptor. Web app. Specify the filter name and the filter class. Filter. Filter name. Hello World filter. Filter name. Filter class. Hello World filter. Filter class. Filter. Associate the filter with a URL pattern. Filter mapping. Filter name. Hello World filter. Filter name. URL pattern. Filter. URL pattern. Filter mapping. Web app. We will see the details of these elements in section 7. 4. You could also copy the chapter 07 directory directly from the Manning website to your C. Jakarta Tomcat 5. 0. 25. Webops directory. This directory contains all the files needed to run the example. Execution. Start Tomcat and enter this URL in your browser's navigation bar. HTTP. Localhost. 8080. Chapter 07. Filter. The browser should display the message Hello Filter World. Notice that we have not put any resource on the server with the above URL. You can enter any URL matching the pattern filter, and the filter will still execute without any problem. Thus, the resource to which a filter is mapped does not have to exist. 7. 2. The filter API. The filter API is not in a separate package. The set of classes and interfaces used by filters is part of the javax.servlet and javax.servlet HTTP packages. Table 7. 1 describes the 3 interfaces and 4 classes used by filters. Table 7. 1 interfaces used by filters. Interface. Class description. Interfaces of the package javax.servlet. javax.servlet. Filter. We implement this interface to write filters. javax.servlet. FilterChain. The servlet container provides an object of this interface to the filter developer at request time. This object gives the developer a view into the invocation chain of a filtered request for a resource. javax.servlet. FilterConfig. Similar to ServletConfig, the servlet container provides a FilterConfig object that contains initialization parameters for this filter. Classes of the package javax.servlet. javax.servlet. Servlet request wrapper provides a convenient implementation of the servlet request interface that can be subclassed by developers wanting to adapt the request to a servlet. JSP. javax.servlet. Servlet response wrapper provides a convenient implementation of the servlet response interface that can be subclassed by developers wanting to adapt the response from a servlet. JSP. Classes of the package javax.servlet. HTTP. javax.servlet. HTTP servlet request wrapper provides a convenient implementation of the HTTP servlet request interface that can be subclassed by developers wanting to adapt the request to a servlet. JSP. javax.servlet. HTTP servlet response wrapper provides a convenient implementation of the HTTP servlet response interface that can be subclassed by developers wanting to adapt the response from a servlet. JSP. 7. 2. 1. The filter interface. This is the heart of the filter API. Just as all servlets must implement the javax.servlet. Servlet interface either directly or indirectly, all filters must implement the javax.servlet. Filter interface. It declares 3 methods, as shown in Table 7. 2. Table 7. 2 methods of the javax.servlet. Filter interface. Void init FilterConfig. Called by the container during application startup. Void doFilter servlet request. Servlet response, FilterChain. Called by the container for each request whose URL is mapped to this filter. Void destroy. Called by the container during application shutdown. The 3 methods of the filter interface are also the life cycle methods of a filter. Since, unlike the Servlet API, the Filter API does not provide any implementation for the filter interface, all filters must implement all 3 methods explicitly. The init method. The servlet container calls the init method on a filter instance once and only once during the lifetime of the filter. The container does not dispatch any request to a filter before this method finishes. This method gives the filter object a chance to initialize itself if required. Here is the signature of the init method. Public void init FilterConfig. FilterConfig throws servlet exception. This method is analogous to the init ServletConfig method of the servlet interface. This method is typically implemented to save the FilterConfig parameter for later use. We will learn more about FilterConfig in section 7. 2. If the initialization fails, The init method may throw a servlet exception or a subclass of the servlet exception to indicate the problem. The doFilter method. The doFilter method is analogous to the service method of the servlet interface. The servlet container calls this method for each request with a URL that is mapped to this filter. This is a signature of the doFilter method. Public void doFilter servlet request, servlet response, FilterChain throws Java. I exception, servlet exception. This gives the filter object a chance to process the request, forward the request to the next component in the chain, or reply to the client itself. Note that the request and response parameters are declared of type servlet request and servlet response, respectively. Thus, the Filter API is not restricted to only HTTP servlets. However, if the filter is used in a web application, which uses the HTTP protocol, these variables refer to objects of type HTTP servlet request and HTTP servlet response, respectively. Casting these parameters to their corresponding HTTP types before using them is a typical implementation of this method. The uses of this method vary from filter to filter. A simple auditing filter may retrieve the request URL, the request parameters, and the request headers, and then log them to a file. A security filter may authenticate the request and decide to either forward the request to the resource or reject access to the designated resource. Yet another type of filter may wrap the servlet request and servlet response parameter objects with wrapper classes, and alter the request and response messages partially or completely. A rather odd implementation is to route the request to another resource using the include and forward methods of request dispatcher. The request dispatcher object can be obtained using request get request dispatcher. In case of an irrecoverable error during the processing, doFilter may decide to throw an exception, a servlet exception, or a subclass of either of these exceptions. The destroy method. The destroy method of the filter interface is analogous to the destroy method of the servlet interface. The servlet container calls this method as the last method on the filter object. This is a signature of the destroy method, public void destroy. This gives the filter object a chance to release the resources acquired during its lifetime and to perform cleanup tasks, if any, before it goes out of service. This method does not declare any exceptions. 7. 2. The FilterConfig interface. Just as a servlet has a servlet config, a filter has a FilterConfig. This interface provides the initialization parameters to the filter. It declares 4 methods, as shown in Table 7. 3. Table 7. 3 methods of the javax.servlet. FilterConfig interface. String getFilterName returns the name of the filter specified in the deployment descriptor. String getInit parameter string s returns the value of the parameter specified in the deployment descriptor. Enumeration getInit parameter names returns the names of all the parameters specified in the deployment descriptor. Servlet context getServlet context returns the servlet context object associated with the web application. Filters can use it to get and set application scoped attributes. The servlet container provides a concrete implementation of the FilterConfig interface. It creates an instance of this implementation class, initializes it with the initialization parameter values, and passes it as a parameter to the filter. Init method. The name and initialization parameters are specified in the deployment descriptor, which we will discuss in Section 7. 3. Most important, FilterConfig also provides a reference to the servlet context in which the filter is installed. A filter can use the servlet context to share application scoped attributes with other components of the web application. 7. 2. 3. The FilterChain interface. The FilterChain interface has just one method, described in Table 7. 4. Table 7. For the javax.servlet. FilterChain interface method. Void doFilter servlet request, servlet response. We call this method from the doFilter method of a filter object to continue the process of filter chaining. it passes the control to the next filter in the chain or to the actual resource if this is the last filter in the chain. The servlet container provides an implementation of this interface and passes an instance of it in the doFilter method of the filter interface. Within the doFilter method, we can use this interface to pass the request to the next component in the chain, which is either another filter or the actual resource if this is the last filter in the chain. The two parameters of type ServletRequest and ServletResponse that we pass in this method are received by the next component in the chain in its doFilter or service method. 7. 2. For the request and response wrapper classes, ServletRequest wrapper and HTTP ServletRequest wrapper provide a convenient implementation of the ServletRequest and HTTP ServletRequest interfaces, respectively, that we can subclass if we want to alter the request before sending it to the next component of the filter chain. Similarly, ServletResponse wrapper and HTTP ServletResponse wrapper are used if we want to alter the response received from the previous component. These objects can be passed as parameters to the doFilter method of the FilterChain interface. We will see how to do this in section 7. 4. 7. 3. Configuring a filter. A filter is configured using two deployment descriptor elements, filter and filter mapping. Each filter element introduces a new filter into the web application, while each filter mapping element associates a filter with a set of request URIs. Both elements come directly under web app and are optional. These elements are similar to the servlet and servlet mapping elements. 7. 3. 1. The filter element. Here is the definition of the filter element. Element filter icon, filter name, display name, description, filter class, init param. As you can see from the above definition, each filter requires a filter name and a filter class that implements the filter. Other elements, icon, display name, description, and init param, serve the usual purposes and are optional. The following example illustrates the use of the filter element, filter, filter name, validator filter, filter name, description, validates the requests, description, filter class, manning, filters, validator filter, filter class, init param, param name, locale, param name, param value, USA, param value, init param, filter. This code introduces a filter named validator filter. The servlet container will create an instance of the manning, filters, validator filter class and associate it with this name. At the time of initialization, the filter can retrieve the locale parameter by calling FilterConfig. Get parameter value locale. 7. 3. To the filter mapping element. This element works exactly like the servlet mapping element that we discussed in detail in Chapter 5, Structure and Deployment. The filter mapping element is defined as follows. Element filter mapping filter name, URL pattern servlet name. The filter name element is the name of the filter as defined in the filter element. URL pattern is used to apply the filter to a set of requests identified by a particular URL pattern, and servlet name is used to apply the filter to all the requests that are serviced by the servlet identified by the servlet name. In the case of URL pattern, the pattern matching follows the same rules for servlet mapping that we described in Chapter 5. The following examples illustrate the use of the filter mapping element, filter mapping, filter name, validator filter, filter name, URL pattern, doc, URL pattern, filter mapping, filter name, validator filter, filter name, servlet name, report servlet, servlet name, filter mapping. The first filter mapping shown above associates validator filter with all the requests that try to access a file with the extension doc, while the second filter mapping associates validator filter with all the requests that are to be serviced by the servlet named report servlet. The servlet name used here must refer to a servlet defined using the servlet element in the deployment descriptor. 7. 3. Configuring a filter chain. In some cases, you may need to apply multiple filters to the same request. Such filter chains can be configured using multiple filter mapping elements. When the servlet container receives a request, it finds all the filter mappings with a URL pattern that matches the request URI. This becomes the first set of filters in the filter chain. Next, it finds all the filter mappings with a servlet name that matches the request URI. This becomes the second set of filters in the filter chain. In both sets, the order of the filters is the order in which they appear in the deployment descriptor. To understand this process, consider the filter mappings and servlet mapping in the web XML file shown in Listing 7. 2. Listing 7. 2. A web XML file for illustrating filter chaining. Web app, filter, filter name, FilterE, filter name, filter class, test filter, filter class, filter, filter, filter name, filter B, filter name, filter class, test filter, filter class, filter, filter, filter name, filter C, filter name, filter class, test filter, filter class, filter, filter, filter name, filter D, filter name, filter class, test filter, filter class, filter, filter, filter name, FilterE, filter name, filter class, test filter, filter class, filter, associate FilterE and FilterB to red servlet, filter mapping, filter name, FilterE, filter name, servlet name, red servlet, servlet name, filter mapping, filter mapping, filter name, filter B, filter name, servlet name, red servlet, servlet name, filter mapping, associate filter C to a request matching, red, filter mapping, filter name, filter C, filter name, URL pattern, red, URL pattern, filter mapping, associate filter D to a request matching, red, red, filter mapping, filter name, filter D, filter name, URL pattern, red, red, URL pattern, filter mapping, associate filter E to a request matching, red, filter mapping, filter name, FilterE, filter name, URL pattern, red, URL pattern, filter mapping, servlet, servlet name, red servlet, servlet name, servlet class, red servlet, servlet class, servlet, servlet mapping, servlet name, red servlet, servlet name, URL pattern, red, 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 URL pattern, servlet mapping, servlet name, red servlet, servlet name, URL pattern, red, URL pattern, servlet mapping, web app. In web XML, shown in Listing 7. 2. We have associated 1. FilterE and FilterB with red servlet using the servlet name and the filter mapping elements. 2. Filter C to a request whose URI matches red. 3. Filter D to a request whose URI matches red, red. 4. Filter E to a request whose URI matches red. We have also configured red servlet to service request having the URI pattern of red, 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 and red. Table 7. 5 shows the order of filter invocations for various request URIs. Table 7. 5 order of filter invocation in filter chaining. We have not shown the base URIs for any of the request URIs in the table, since it is the same for all. HTTP localhost 8080 Chapter 07. In Table 7. 5. Observe the following points. The container will call the filters that match the request URI URL pattern before it calls the filters that match the servlet name to which the request will be delegated servlet name. Thus, FilterC, FilterD, and FilterE are always called before FilterA and FilterB. Whenever called, FilterC, FilterD, and FilterE are always called in this order since they are configured in this order in the web XML file. Whenever red servlet is invoked, FilterA and FilterB are called in this order, since they are configured in this order in the web XML file. We have provided this test application on the Manning website. You can try it out with different request URIs and see the results. 7. For advanced features. In addition to monitoring the communication between the clients and the web application components, filters can manipulate the requests and alter the responses. In this section, we will learn about these features. 7. 4. 1. Using the request and response wrappers. All 4 wrapper classes Servlet Request Wrapper, Servlet Response Wrapper, HTTP Servlet Request Wrapper, and HTTP Servlet Response Wrapper work in the same way. They take a request or response object in their constructor and delegate all the method calls to that object. This allows us to extend these classes and override any methods to provide a customized behavior. In this section, we will use these classes in a filter to solve a simple problem. We have a legacy system that generates reports in a plain ASCII text format and stores them in a text file with an extension of txt. We want these reports to be accessible from AAA FilterC, filtered none 404 Arab browsers with an image displayed as the background of the report. For example, Figure 7. 3 shows how a sample report should display on the browser. Figure 7. 3a sample report with a background image at the same time. We also do not want the browser to cache the report files. These 2 problems can be easily solved if we are able to do the following. 1. Embed the text of the report into HTML and body tags with an appropriate image as the background. HTML body background equal text report. GIF pre text of the report here. Pre body HTML. The background attribute of the body element will display the given image as the background of the report, while the pre tag will keep the formatting of the textual data intact. 2. Override the if modified since header. Browser send this header so that the server can determine whether the resource needs to be sent. If the resource has not been modified after the period specified by the if modified since value, then the server does not send the resource at all. For this purpose, we will filter all the requests for files with the extension txt. Our filter will do 2 things. 1. Wrap the request into an HTTP servlet request wrapper and override the getHeader method to return null for the if modified since header. A null value for this header ensures that the server does send the file. 2. Wrap the response object into an HTTP servlet response wrapper so that the filter can modify the response and append the required HTML before sending it to the client. Let's now look at the code that implements this. Listing 7. 3 shows the code for non-catching request wrapper. Java, which customizes the behavior of HTTP servlet request wrapper. Listing 7. 3. Wrapping a request to hide a header value. Import javax. Servlet. Import javax. Servlet. HTTP. Public class non-catching request wrapper extends HTTP servlet request wrapper. Public non-catching request wrapper HTTP servlet request rec super rec. Public string getHeader string name. Hide only the if modified since header. And return the actual value for other headers. If name equals if modified since return null, else return super. Get header name. The code for non-catching request wrapper is quite simple. It overrides the getHeader method and returns null for the if modified since header. Since this class extends from HTTP servlet request wrapper, all other methods are delegated to the underlying request object that is passed in the constructor. Listing 7.4 shows the code for text response wrapper, which customizes the behavior of HTTP servlet response wrapper. Listing 7.4 wrapping a response to buffer text data. Import Java IO. Import javax.servlet. Import javax.servlet. HTTP public class text response wrapper extends HTTP servlet response wrapper. This inner class creates a servlet output stream that dumps everything that is written to it to a byte array. Instead of sending it to the client, private static class byte array servlet output stream extends servlet output stream byte array output stream base. Byte array servlet output stream byte array output stream base. This base equal base. Public void write in param throws Java IO. I exception base. Write param. The actual byte array output stream object that is used by the print writer as well as servlet output stream private byte array output stream base equal new byte array output stream. This print writer is built over the byte array output stream. Private print writer PW equal new print writer base. This servlet output stream is built over the byte array output stream. Private byte array servlet output stream bossos equal new byte array servlet output stream base. Public text response wrapper HTTP servlet response super response. Public print writer get writer returns our own print writer that writes to a byte array instead of returning the actual print writer associated with the response. Return PW. Public servlet output stream get output stream returns our own servlet output stream that writes to a byte array instead of returning the actual servlet output stream associated with the response. Return bossos. Byte to byte array return base to byte array. The code for text response wrapper looks complicated but is actually very straightforward. It creates a byte array output stream to store all the data that is written by the server. It overrides the getWriter and getOutput stream methods of HTTP servlet response to return the customized print writer and servlet output stream that are built over the same byte array ODAT stream. Thus, no data is sent to the client. Listing 7.5 shows the code for text to HTML FILTER. Java, which converts a textual report into a presentable HTML format as required. Listing 7.5 code for text to HTML FILTER. Java import Java IO. Import javax. Servlet. Import javax. Servlet. HTTP. Public class text to HTML FILTER implements filter private FilterConfig FilterConfig. Public void init FilterConfig this. FilterConfig equal FilterConfig. Public void doFilter servlet request servlet response FilterChain throws servlet exception I exception HTTP servlet request rec equal HTTP servlet request HTTP servlet response res equal HTTP servlet response non-catching request wrapper NCRW equal new non-catching request wrapper rec text response wrapper TRW equal new text response wrapper res passes on the wrapped request and response objects FilterChain doFilter NCRW TRW string top equal HTML body background equal text report GIF pre string bottom equal pre body HTML embeds the textual data into HTML body and pre tags string buffer HTML file equal new string buffer top string text file equal new string trw, to byte array, HTML file, append text file, HTML file, append, br, plus bottom, sets the content type to text, HTML res, set content type text, HTML, sets the content type to new length res, set content length HTML file, length, writes the new data to the actual print writer pw equal res, get writer, pw, print on HTML file, to string, public void destroy the code in listing 7. 5 wraps the actual request and response objects into the non-catching request wrapper and text response wrapper objects, respectively, and then passes them on to the next component of the filter chain using the doFilter method. When the filter chain doFilter call returns, the text report is already written to the test response wrapper object. Our filter retrieves the text data from this object and embeds it into the appropriate HTML tags. Finally, it writes the data to the actual print writer object that sends the data to the client. Deploying the filter. As explained earlier, deploying this filter requires 2 steps. 1. Copy all the class files to the webinf classes directory. 2. Set the filter and the filter mapping in the web XML file of the web application as shown here. Filter, filter name, text to HTML, filter name, filter class, text to HTML filter, filter class, filter, filter mapping, filter name, text to HTML, filter name, URL pattern, txt, URL pattern, filter mapping. If you have copied the Chapter 07 directory to the WebOps directory of your Tomcat installation, you can open the given web XML file and see the settings. Running the application. To run the application, restart Tomcat and request any text file that is available in this web application from the browser. For testing purposes, we have provided a sample text file and a GIF image. You can view them through this URL, http localhost 8080 Chapter 07 Report Gen Feb txt7 4. 2 important points to remember about filters. You need to understand these points when using filters. There is 1 filter per filter entry in the web XML file per virtual machine. A servlet container is free to run multiple threads on the same filter object to service multiple requests simultaneously, as of Servlet Spec 2. 4. Filters can now be configured to be invoked on any combination of the following. As a result of calling request dispatcher. Forward. As a result of calling request dispatcher. Include. On error pages, the execution points used are controlled in the filter mapping in web XML. If not specified, a filter will only be invoked on incoming requests. In the example below, all possible ways to invoke a filter have been enabled. Filter mapping, filter name, access log, filter name, URL pattern, dispatcher, request, dispatcher, forward, dispatcher, include, dispatcher, error, dispatcher, filter mapping. 7. 4. 3. Using filters with MVC. As we discussed in Chapter 2, Understanding Java Server Pages, the JSP Model 2 architecture is based on the MVC design pattern. It breaks a web application down into 3 distinct areas, where the Java beans act as the model, the JSP pages act as a view, and the servlets act as the controller. A request, or a group of related requests, is actually handled by a servlet, which retrieves the data and creates Java beans to hold the data. After creating the beans, it uses a request dispatcher object to forward the request to an appropriate JSP page. The JSP page uses the beans and generates the view. This approach works well when the view to be displayed is determined by the business rules. For example, The page that should be displayed after a user logs in may depend on the access rights she has. Therefore, the final presentation depends on the servlet code that decides which JSP page the request is to be forwarded to. Now consider another situation. An application is required to display some reports in either XML or HTML format as requested by the client. For this purpose, you develop two JSP pages: XML view, JSP, and HTML view, JSP. You also develop a servlet that generates the data needed by both the JSP pages. In the Model 2 architecture, the client request would go to the servlet. The servlet would retrieve the data and then dispatch the request to either XML view, JSP, or HTML view, JSP. The problem with this solution is that the servlet needs an extra parameter in the request that will indicate which view is being requested. Furthermore, the servlet will have to hard-code the names of the JSP pages. This means that adding a new view will require a code change in the servlet. Filters are very useful in the situation described here. We can code the servlet's logic of retrieving the data and creating Java beans in a filter and apply this filter to both views. The user can directly request the XML view, JSP, or HTML view, JSP page. Since the filter will be executed first, the necessary beans will be available when the request reaches the JSP page. This architecture eliminates the need for an extra parameter to inform the filter about the view. This information is already present in the name of the resource given in the request. It also provides a clean way of adding a new view. For example, if we need to provide a text view, we can develop a text view, JSP file and apply the same filter on this JSP page. There is no code change in the filter. Thus, in such situations, filters are a better choice for controllers than servlets. 7.5 Summary. Filters add value to a web application by monitoring the requests and responses that are passed between the client and the server. With filters, we can analyze, manipulate, and redirect requests and responses. In this chapter, we learned about the Filter API, including the three interfaces Filter, FilterConfig, and FilterChain, and we saw how to configure filters in the deployment descriptor. We then looked at the way we can use a filter to wrap a request or response in a customized object before delivering it to its destination. Within the MVC model, filters, rather than servlets, can better play the role of a controller in some situations. 7.6 Review questions. 1. Which elements are allowed in the filter mapping element of the deployment descriptor? Select 3. A. Servlet name. B. Filter class. C. Dispatcher. D. URL pattern. E. Filter chain. Answers: A, C, and D. Explanation. Answer A is correct because you can map filters to name servlets, as well as URL patterns. Answer C will control under which dispatching mechanism the filter is invoked. Answer D allows you to map the filter to an URL pattern. Answer B is a legitimate element, but it belongs in the filter element. Answer E is a non-existent element. 2. What is wrong with the following code? Public void doFilter servlet request rec, servlet response, res, filter chain throws servlet exception, I exception chain. doFilter rec, res. HTTP servlet request equal HTTP servlet request rec, HTTP session equal request. Get session. If session. Get attribute login null session. Set attribute login, new login. The doFilter method signature is incorrect. It should take HTTP servlet request and HTTP servlet response. B. The doFilter method should also throw filter exception. C. The call to chain. doFilter rec, res should be this. doFilter rec, res, chain. D. Accessing the request after chain. doFilter results in an illegal state exception. E. Nothing is wrong with this filter. Answer: E. Explanation. Answers A and B are wrong. The doFilter method's signature and thrown exceptions are correct. Answer C, calling this doFilter res chain would result in unwanted recursion. Answer D is incorrect. No code here will throw an illegal state exception. 3. Given these filter mapping declarations: filter mapping, filter name, FilterOne, filter name, URL pattern, admin, URL pattern, dispatcher, forward, dispatcher, filter mapping, filter filter name, filter2, filter name, URL pattern, users, URL pattern, filter mapping, filter name, filter3, filter name, URL pattern, admin, URL pattern, filter mapping, filter name, filter2, filter name, URL pattern, filter mapping. In what order are the filters invoked for the following browser request? Admin, index, JSP, A FilterOne, filter3, B FilterOne, filter2, filter3, C filter3, filter2, D filter3, filter2, E filter3, F. None of these filters are invoked. Answer D. Explanation: FilterOne cannot be invoked by calling admin, index, JSP from the browser but only through a request dispatcher forward, so answers A and B are incorrect. Answer C lists the correct filters but in the wrong order. Answer E names only the first filter that is invoked. Answer D names the correct filters in the correct order.